The experiment of John Bell essentially demonstrated that you cannot make the following assumption. You cannot make the assumption that in an experiment of the kind that he was proposing, in this experiment there are two experimenters in two regions that are space-like separated. That means they're separated in such a way that no information from one can get to the other without moving faster than the speed of light. So you have the two experimental regions, and in each region the experimenter is free to choose at the last moment whether he's going to do this experiment or that experiment. Same over here. And then each of the experiments has two possible outcomes. And it was natural to assume, on the basis of what people thought, that the following, that the result appearing in one region should not depend on the choice made by the experimenter at the last minute in this region. This choice made by the experimenter in this region was made at the last minute. There's no time for that information to get over here. So the presumption is that, therefore, whatever happens here, the outcome of this experiment, cannot depend on this choice, and the other way around. And the upshot of the experiment, well, in the first place, quantum theory predicted, if you looked at the predictions of quantum theory and the way it works, you found that the predictions violated that presumption. So there are two things that could happen. Either the experiment would turn out to demonstrate that quantum theory was wrong, or if they demonstrated that quantum theory was right, then there was a huge puzzle. I mean, it would mean a profound failing of what people had believed up until that moment about the physical universe, and a profound failing of our normal understanding of how the universe works, even probably before that. And so, in fact, the first experimenter to do it was John Clauser, was at the University of Berkeley at that time, and he assumed that he would win the Nobel Prize because he was sure that information could not travel at the speed of light. Therefore, the predictions of quantum theory would be wrong. His experiment would show that quantum theory was wrong, and that would be a sure Nobel Prize discovery. He was wrong. The experiments absolutely confirmed the predictions of quantum theory, and you're left with the conclusion that somehow there's an instantaneous sort of transfer of information. Somehow what happens here cannot be assumed to be independent of how the choice is made at the last minute here. And so that's what, and so that's what the Bell's theorem is all about. And the point is that that means that somehow nature seems to have a non-local, seems to be acting non-locally. I mean, the material picture of the universe that existed before everything was kind of, you know, this causes this, it's all kind of a contact connection. This is just a totally, you're forced to deal with a totally different reality here about how quantum theory, about how nature works. And so, of course, for those who want to believe that there's somehow a cosmic mind working, this is something that they can point to and say, well, you know, this looks like it's moving in that direction.